Okay, so hi everyone. Today we're starting a review of Python data structures and algorithms, which I've already started doing. I decided to start earlier today in hopes that my mind would feel like coding at this time of day. And so we're at the tail end of what I've been working on, but I wanted to show you guys some resources. So this is purely data structures and algorithms. You'll need something else for like software development. But I like this website called Runstone Academy. It's donation based. It's kept by a bunch of different schools, um, and do donate if you can. But they have a list of a list of courses on all these topics, and a lot of the books are kind of open source versions. Like the first book I read was How to Think Like a Computer Scientist. Um, That was a decade ago. And I found this website probably 6 or 7 years ago. But you have a lot more newer stuff actually these days. Then the last time I used it, I was like, okay, what's in my log of resources for Pythonic review? And so the reason why this is going to be useful for you, because we're in data structures for Python. I'm actually going to come and do the C++ one or the C one because I would like to get into CUDA programming. But I don't want to do C++. I want to do C so I can. Most of what you can do in C, you can do in C++. Um, but I think C is going to be closer to what I need to look at. But we're doing uh, Python problem solving with algorithms and data structures in Python, edition 3. You want edition 3. You want the updated version, not the version I learned on, but the version that's updated. Um, and I didn't go through all of this because I know a good bit of it, but this is kind of the stuff that you'd want to go through and understand before you start LeetCode. And since my day-to-day job does not involve algorithms, it involves experimentation, I am thoroughly rusty on these concepts. And I do think, and if you're not listening to me, that the data science market is moving toward more software engineering enabled data roles for the data science, not pure experimentation, but able to handle more full stack deployment, DevOps, as what a software engineer, converting their code for production, not just for experimentation. These are skills that you need to know is how to build from the ground up. So earlier today, I went back through the algorithm analysis chapter, trying to refresh myself on count and compare, sort and compare. And then I went through stacks. And so now I'm here, infix, prefix, postfix expressions. That's all before we get to Q. And you'll notice a lot of easy level LeetCode answers here. I also have the Python documentation up because they typically go through stuff that I just don't use. I mean, I'll code in pandas if I need anything, and pandas is just not production ready, even though we're coming out with like Polars, and I think Mojo Python is coming out soon. Um, Dask or distribution, this is really just Python coding, right? So I'm here, and so I was going to take some time to read through this and finish this out before finish this up by the end of the hour and go from there. So, in case you know, when you write the algorithmic expression, v dot c, or I guess times, so we're looking at provides you information you need to interpret. In this case, we know that the variable being multiplied by variable b, since the multiplication operator appears between them. Yeah, that's confusing because I think of that as dot now. We should have used the x. It's screwing with my mind. Okay, consider another infix example. Each operator has a precedence precedence level. Operators of higher precedence are used before operators of lower precedence. Only then, like the operators. This is going to go to operator and expression. Okay. Infix is this. Prefix is operator here. Postfix is the stuff is there. Infix, prefix, postfix. We're used to infix, prefix, postfix. Okay. This is going to be converting infix to prefix. Why would I want to do that? Seems like a lot of trouble to me. Ton of trouble. Oh goodness. It's been a long day. I'm going to try to demonstrate how operators need to move. And honestly, this is all about learning the stack more than it's about learning prefix and postfix. Plus B dot minus dot plus. Okay. Okay. So we create a stack. Create an empty list for output. Convert the input infix string to the list by using a string method. Scan the token to the left and the right. If the token is operand, append it to the end of the output list. The token is a parentheses, push it to the stack. So we push the parentheses to the stack. We push the left and pop the right, which is what I've been doing all day, until all of the ones on the left are moved. Operated to the end of the list. Okay. Now, this is what I do. So this is not a built-in function. There is a built-in stack in Python now, but they made this, and I have the code in my notebook. You'll have to go back a few lessons to get their code to do it their way. But I don't like to run the code. I mean, it runs so it knows that I did it, but being self-taught and how I learned algorithms was I just put print statements at every section of the code, and I print it out what it's doing and what the value changes to. And so here they actually sometimes have this section where you can like walk through where it's at and it'll tell you what it's doing, but they don't always have that, and so you can't always know. And so the best way I find to ensure that I know where any errors are in the code or what that portion of the code does is it giving me what I expected to get is I put a bunch of print statements in there. And so let's read it down. So here we get the precedent, and they're just giving values to each one of these as numbers. Everything that would be in the front. This is just creating a dictionary of these. And they add it to that, and they give it to the value of 3, 3, 2, 2, 1. And that's the order of precedence, right? So multiplication, division, math, and addition, and then the parentheses. So now we're creating a stack, and they're creating a postfix list. And they take in this, and they split it up into a list so that we're working with all the same data formats. All right. So for token and token list, so if it's a number or if it's a letter. So basically variables are numbers. And actually you can use like is alpha or is digit. But again, they're trying to do it without using methods and do it 100% scratch. And sometimes methods can take longer too. So they have a whole section on O notation, which I understand O notation. I just don't ever get to use it. So I understand code optimization techniques. And I do actually, never mind, I do use it, but not as often as you would think. Okay. So they push to stack. So first they, for any token in this list, if it's one of those, we're going to append it to this list here. Then if it's this, we're going to push to the stack so that we can keep a hold of all of the opening parentheses. If it's not, if it's at the back, you're going to push a top token. You're going to pop it off. And while it's not the beginning, that means we've gone through all the beginning, we're towards the back, and it pops. That prefix list, you're going to append the top token, which is what you popped at the end. And then top token, pop again actually. Let's add in some print statements. And so only thing I do here is, I get what this does, I get what this does. We're stuck here. So I want to know the value of top token. And so I'm just going to copy the variable name in the variable spaces. And it's the first time it's mentioned, so I'm just going to say top token 1. And we're going to say top token 2. While not op stack is empty. So while while it's not empty, so while it's still full. So if all of these statements are wrong and you can peek into it, is greater than the current token, append postfix list stack pop. So I need to know the value of postfix list here. Okay, so let's do this. This is going to be postfix list 1. I'm just going to change that. All right. And we're going to go here. I'm going to go to that was 2. This is 3. And the numbers are just telling us where in the location of the code we're talking about when it happens. 4. And the only reason I don't pull stack is because it's an object, and it will just say it's an object. It won't tell me the object values. I forget how to pull stuff from objects right now, so yeah, we're gonna put one here. 5. Okay. And so we're only going to do one at a time. And there we go. So we start here, postfix this 1. And it stays here because there are no parentheses or anything else. So it goes through everything here, B. Now we first get to this one. We jump from 1, 2 to 1, 2 down here to, because it's not in here, it's not any of these, and so we're jumping here. So we get to postfix this. Oh, this is 5. And this is 6. Let's run that again. So we're jumping, is it 5? Yeah, so we jumped here to 5. So here, not stack empty. So the not empty. Let's see what we mean. So A, B, C, star. And present, P greater than. Actually, I want to print this too. Let's print both of those. Print statements are your friend. And I am totally overusing the print statement, but actually we'll call it 3. We'll call this 2. And I'm going to call this 1. Oops. I have no idea where this highlighted. Okay. So there we go. So 2 precinct 1. So it falls into this while loop, and this precinct is 3 and this precinct token is 2 because we're looking at 3, right? So since precinct, we are so it's not empty. So they checked if it's empty, and we're checking if it's not empty, which is true. There's a bunch of wait. OP stack would be OP stack is a stack. We don't have any parentheses, so why wouldn't it be empty? See, this is why I ask all the questions. So OP stack is empty is true. OP stack pop. Postfix list append. Whatever you popped from it. We know it can't have OP stack, right? We've not added anything to the token. So OP tech push token if it was. If left token, which we don't have either. So how do we get it's empty? It's not empty. OP stack pop. I feel like I'm missing something pretty major here. Let's do this. Is that one more statement? Okay. So is empty equals false. So false, not false, is true. Let's make some copying. I have a feeling I'm thinking about my booleans backwards, which is fine. Let's put one here. It's going to be OP stack 1 now. OP stack 2. OP stack 3. OP stack 4. And this is going to be OP stack 5. All right. So OP stack 1. It is empty here. We load all this code in and it gets to OP stack 5 here. And it's saying that it's not true, that it is no longer still empty. But we didn't run OP stacks 2 through 4. So how can it not be empty? I get that. Fascinating. So then it goes back to CD at the top, 1, 2, 1, 2, drops down to 6. So now this is fascinating code because I feel like I'm missing something when it comes to the precincts for sure. Because it jumps down to 6 for star and plus this time. It skips this whole thing. I'm going to add print statements again. I'm gonna put postfix list. No, it tells me the postfix list 6. There are no precincts. So while this is an OP stack one. Let's add OP stack here. OP stack 6. So now it's false, right? We stack 7 false. So now it's, by the time we get here, it's true that it is empty. And then join as a string, which makes sense. So I need to understand this bottom part of this code. I get the top half. Top half makes sense. I get lost here. So this is a dictionary. And we have a postfix list, which is what we're appending everything to from the token list as we sort through everything. Which makes sense. We do want to sort through everything. Well, this 1, 2, 1, 2, it doesn't touch any of those. So I'm not understanding this statement. So is empty is true, not is empty is false. But it is empty. So it didn't append anything to it. Unless I'm missing something in this code. It didn't show up till false. I get 4 other places to look for it. But none of these matter, which is why it didn't run it. Because there are no parentheses for it to run. This is bigger than that. It was 3 and it was 2, which makes sense. This is an and statement. Both need to be true. So this is greater than this, which is true. Is empty would be true. This is a not, so that'd be false and true. Okay, let's look up is empty again in Python. I am missing something. Maybe it doesn't return like I think it returns. Oh, let's go up here. Part of this special thing in there. self item, so it's a bool. Return not bool. Returns true when the argument is true, false otherwise. Okay, so check if the stack is empty. Bool, not bool. So it undoes it. Because empty would be false. And so they made is empty would be true. Okay, that explains it. So is empty true? And then not true is false. Which is why we have false. Whew, okay, got through that part. Now, precinct 2, which is this one, is precinct 2 is 3 and token is 2, so false. And this is greater than or equal to, which is true. Well, I'm guessing that's false. So peak, let's go back up to this function they made. Get the value of the top item in the stack minus 1. Because the top of the stack is lower in the stack, right? It's not the base, it's newer. So that's why that would be false. Let's actually print out what that would be. Like, what do you really want to return? Okay, let's do this. So now we have pre4 is true. So this is true. So this is true. It's not true. It's true. Not false. True. That logic is so confusing. So I get it. It's true and true. I don't know why they wrote it that way. But I feel like I'm back in that dumb class I fell asleep in. Set theory. So much times. Okay, got it. Okay. So that gives us that. And this has the parentheses, so it'll just print out a much longer version. And more examples. This is now postfix, which is doing this all in reverse. Like you want to put it at the all at the end of the stack with the signs. Ooh. Give me a minute. I feel like my brain just had a revelation. It just got back from outer space. It really is hard to keep up with like computer science, software engineering fundamentals when. Anyway, I think I've said that a lot. My brain hurts. Okay. So this is the pseudocode that they typed out, and this is the actual code that they did it with. We're going the opposite way. So in this case, we're not dealing with variables, right? They just did their numbers. So they create that op stack again. And it's host operons. And the token list. So in the token list, if it's there, it's going to all push to the operon stack.push the number of the token. Yeah, they turn into numbers from this token list because it's a string. Else, they're going to pop it and the pop from the stack. Do math. And they may do math, so I got it. this is different. So if this, then multiply this way. If this, multiply op 1, 2, 3, 4. So this is doing the math of how this goes. So if you put it in this way, doing the reverse as a postscript evaluation, all the operands at the end, and you're going to actually do the math, you're going to get out 3. So the reason being is you passed in these numbers. So first thing it's going to do is going to have 7 and 8, and you're going to push the tokens to that list. The next thing you're going to do is get this thing here, and you're going to pop it twice. You're going to grab that token, get the operand. Okay, let's visualize this thing. Bring it to life. Let's grab some handy dandy code blocks or print statements. All right, so let's start here. We're going to get the token before it's pushed. First time we talk about a token, so we're just going to say T1 and token. There we go. Actually, okay, it's so confusing. It's probably I got a C, I think, or a D and set there. College. Okay, token. Let's get operand 1 and operand 2. Because they should be the last things, I'm guessing. Result. Okay. Now we're going to go here. And this is press play. So let's take it one. So token 1, token 2. Next we get operand 7 and 8. And then we get token 1, token 2, operand 7 and 8. Okay, let's. We're going to get result. Okay, so we got this, and then we got the postscript, which is the operand. That got us 15. They pushed it to the operand stack. Then they did it again, and we got 2, 3 plus, got 5. Then we got So 3. Oh, then we did the division. Oops. Which would be 15 divided by 5, and that's how we get 3. So why did we append result? So since we have all of these tokens out, it just did pop the last one. The last one we put in would be the token. No, hold on. I don't get that. We got 3. And I know you're probably like, how is she so slow? I am very slow. Okay, so let's look here. So we went through the first part. Now, it appends the output of the do math to the stack. So really what our stack looks like is op stack. 7, 8, 5, 1, 5. Oh, 3, 2, 5, 1, 5. That's what the op stack looks like because we pinned the result there. Now, token. Okay, so we would have done this in append each time. If there's an additional token left, which there is because there's still a token left, we loop through here and get 15 and 5, 5 and 15. Because 5 happened last, and we call the second one first, and we do the division. Okay, got it. Whew. All right. We need to convert this here. And actually, you can just use it from here. Just scroll up, and you can edit the code. So save and run. Hold on, did I put in the right one? Oh, without using that. Okay. That's going to be stuff. 10, 3, 5. Star plus 16, 4 minus, divide the whole thing. Numbers need to be in the same order as the original equation. So apparently I have some of the worst answers. Let's go back up to the postfix. Postfix A, B plus star. Okay. Let's do this again. A 10, 3 plus 5 star 16 minus 10, 3, 5. Huh. I don't know what I'm doing wrong. Because I kept them together. I don't know why the plus with this one would be at the very end. Why do my brain need to know this? I get that I'm learning stacks and cubes. I get that I'm trying to learn stacks. But math makes my brain hurt at this level. Let's try again. Scroll up. So if it looks like this, A plus B is going to be A plus this on the outside. So let's look at it again. A plus B times C is dot plus. So how does mine look? Okay, I wasn't wrong. This goes here. 3 dot plus. That reverses the sign. I was right the first time. Then it's in the parentheses, which that part is parentheses. It comes out of the parentheses plus. And then the one that's in the middle is at the end. I was right the first time. Wonder if it just needs spaces. My operators aren't in the correct order. Yeah, so the first time it was the spaces. This was right. This might be plus dot. That's about all I can think of that needs changing. Okay, so this wasn't it. So, I don't know. It feels to me like their little checker thingy is out to get me. This is what I have. I don't know why I would move my plus further out. So I've got to figure out why my plus needs to go further out when my plus is between the 10 and the 3. Let's go here to something a little bit bigger. So when looking at this, right? DE, the plus is here. FG, the plus is next to it. The dot between them. Oh, order of operations silly. The plus here to here takes precedent. And so does... No, that doesn't make sense because there's no parentheses. I just gonna have to not get this one. I don't think I can figure that out. I feel like that's wrong because it would have to be parentheses here and here. Right? I don't know. I have a public school education in math. If I do this, that's 27 times 9. Calculator. 243 divided by back to the stat. Oh, okay. So 1710 plus is 27. That sits on the stack. That's one. So then we push the 3 times 9 because those don't actually go together. Three times 9 is, I don't know. Three times 9 is another 27. If I divide it by each other, then it's 1. Check me. No, it's not 1. And this is here. So what are we multiplying by? It's not 1. Not how we get 9. Oh my goodness. Okay. I'm reading this stack wrong. So we have it copied here. Let's go back to the top. Look at the postfix. Again. So we started something like this. 10, 3, that is 27. Now, the next thing we get is a number times a number, which is 3, times 9. Which doesn't feel right if this is supposed to be a postfix. So maybe 27 plus 3, 7, 28, 29 times 9. Divided by equal. What does equal mean? It's like an assignment in code. It doesn't make any sense in like regular math, right? Let's see. Okay. Equal copy. So we're making a numerical comparison to 9. This is when I need someone to explain math to me. This is divide. It's popping from my empty list and I don't know why. I guess, let's see if I can do this. And pizza. Yeah. Pop from empty list. As an indexer. I don't understand. It is 9. That's the most submitted answer. But why is it 9? I feel like we should just be writing math in the way math is written. Left to right. Why are we trying to do math from right to left? Who created this? To spoil my day. That's what I feel like this is being created for. To ruin my day. And my day is effectively ruined. What if I did 27 times 3 divided by 9? Let's try that. 27 times 3 divided by 9. Yeah, that's it. 27 times 3 divided by 9. I don't know what it looked like originally, but that's what it is. Man, the pain. Okay, so this function has to be modified to run this. Let's see in what way. Okay, it needs a caret. So I don't know. This is either going to be a 4 or a 3. I'm going to call it a 4. Pretty sure I put it. Oh. I did only add one line. How dare it think I added 2? Okay, let's change that back to 3. See if that changes anything. I did only add one line. That's exactly what I have. No, it's not. Okay, so it's not a 3. You know what? What if it's a 1? 3, 2, or 1. It's not doing it. I feel like this is rebelling against me. Oh, you know what? Maybe I'm not actually pressing play. Oh, man. I did only add one line. That's where it needs to go. The question is the order of the operation.
Exponentiation in it. I think that has enough parentheses there. Let's just see. Put in this test case. So, okay. So we can go back down here and let's just use copy and paste. And we'll go back up here and we'll put in this test case. Exponentiation is a binary operation, but it's a higher precedence than everything else. So this is actually going to be a one-line change. We can put in our higher.
That's what I did first. It is what I did first. And it didn't take it. Oh my God. This coding thing is out to get me. I did that first. So why didn't you take it? Oh my God. Had me think I was losing my mind. Had me thinking I was losing my mind. It's a one-line change. I did that first. Okay. But now you did is copy. That's what I got.
All right. So 5, 3, 4, 2. So notice that everything is still in the right order. So we do the subtraction first, which we would need to do. Okay. So paste in the answer. So we can do that.
It's just not taking my copy paste. How dare it?
Paste in the answer. Check me. And there we go. We're all correct.
Lies. Think it's screwing with me. That's all it's good for. It's screwing with me. It's the same answer as everyone else. That was the first thing I did. Okay. Forget about it. Forget about it. Okay, we'll come back and do Q's tomorrow. And I think in the afternoon I'm just going to review stacks, like the formatting of stacks. Like, what do you do first? What do you do second? What do you do third? So that anytime I see something where I need to compare things or move stuff around, I will remember the stack architecture. All right, cool. Thanks for tuning in. See you guys tomorrow. Same time, same place.